So let's find the volume first. And we're finding the volume. Well, actually, no matter what we're doing, the first thing we got to find is the area of the base. So I'm going to blow this back up a little bit so I got a little more room to work. So finding the area of the base, we have this one here is a rectangle, which is going to be 10 by 8, or 80 square feet. This one here is a rectangle, which is going to be 12 by 8, or 96 square feet. You guys get those two pieces? Okay. Next, I'm going to put these two pieces together. Piece 3. I'm going to put those two half circles together to make one full circle, which will have an area of pi times 4 squared. 50.24 square feet. Now you might be wondering, why didn't I divide it by 2? Because they're half circles. Because I put them both together to make one full circle. Piece 4 over here is pi times 8 squared. Why is it 8 squared? Yeah, well, 8 across here is the radius. Even though it's the diameter of this circle, it's the radius of this one. The bigger circle. But I'm going to divide by 4 because it's only a quarter circle, which multiplies out to make 50.24 square feet. Which gives me the area of my base of 276.48 square feet. How many of you got that? Okay, so now what do I do to find the volume? Perfect. The area of the base, 276.48 square feet, times my height of 20 feet, which is going to give us 552 9.6 cubic feet. 5529.6 is what you got. That is our volume. Questions? We're doing surface area. At 276.48 square feet. 276.48 square feet again because there's a base on top. And now, of course, I have to find the lateral area. To find lateral area, I need to find the perimeter of the base. Well, let's look at the base. For the perimeter, I've got 12, 12, 10, and 10. Plus, I've got the circumference of these circles here, right? Those two can come together and make one full circle. That circumference is pi times 8. Where'd the 8 come from? That's the diameter. Pi times diameter for circumference. So that's 25.12 feet. Then over here, I've got this quarter circle. That arc length is coming from the circumference divided by 4. So my circumference there is pi times 16 divided by 4. Where did 16 come from? The radius is 8. The diameter would have to be 16. So that's going to give me 12.56 feet. Which, if we add that all up, we get 81.68 feet, correct? Perimeter base? Yes, no? Okay. You see how I got it?
Yeah.
Tate? Looking for a sharp stick?
Yeah.
Do you see what I'm doing? Straight. Your step straight? So, perimeter of that base. Now for our lateral area, we're going to use the perimeter of that base. So the 81.68 feet times our height of 20 feet, which is going to give us a lateral area of 163.36. Correct? Say no. $1,633.6 square feet. Does that sound better? So then, to get our total surface area, we add this mess all up. $2,186.56 square feet. My total surface area. What do you think? Let's do something more fun. So obviously that's just an upside down cone. That's a half a sphere sitting on top of it. We're going to give this a radius of 8 feet. We're going to give this a height. I'm going to be really mean. Why not? Because I can. Overall height, top to bottom, 23 feet. I want you to start out, I'm going to have you start out by just finding the volume of this. We'll do that first. Because we've got to do this in two distinct pieces. We'll start out with the cone first. Now for the cone, we have to have the area of a base. The area of the base is going to be this circle here with a radius of 8. So pi times 8 squared, which is going to give us what? 200.96 square feet. So then the volume of that cone, 200.96 square feet, times, we need to know its height. What's its height from here to here? 15. How do I get 15? The radius of this is 8, so it's going to be 8 from the middle all the way up to the top. This has got to be 8 here. So yeah, 23 minus 8. That circle, that sphere, not only does that radius go every direction on the flat surface, it goes every direction up and down too. So we got 15 feet. Then of course this is all divided by 3, which gives us 1,004.8. Correct? That's the volume of the cone. Next, we need the sphere. The volume of the sphere is 4/3 times pi times the radius cubed. 4/3. Always 4/3. I think you asked that on Monday too. I was wondering if you're going to get that backwards because I remember you asking that, saying that. Sure. So 4 divided by 3 times 3.14 for pi times 8 to the power, not divided by, to the power of 3. 2143.57. Now what do I have to do with that yet? Divide by 2. What do I have to divide by 2? It's only half a sphere. There you go. 1071.79. You know what? We're going to do 1071.8. Make it easy on ourselves. So we add this up. It is 2,076.6 cubic feet. Is our overall value. Anybody come close to that? Okay. Next, give you a few minutes to try the surface area. Well, let's see how we did on surface area. Once again, we're going to have to separate this by cone and sphere. On the cone, do we need to use the area of the base? Is the area of the base exposed? No, it's covered by that half sphere. So the area of the base is technically not part of the surface. Does that make sense?
Yeah.
So we don't need the area of the base. All we need, the only part of the cone that is exposed is the lateral area. So we just need to do lateral area. Now as we work on lateral area, there's two things we need. We need the perimeter of the base, which, since that's a circle, is just a circumference. That's going to be pi times diameter. Since the radius is 8, the diameter is going to be 16, which makes that 50.24 feet. Perimeter of the base. Will we take that times the 15? Say no. Where did the 17 come from? Perfect. We make a right triangle here using that height of 15 and the radius of 8 to get this here, which is our slant. Which, yes, that is going to be 8 squared plus 15 squared equals that slant squared. If you finish that off, you're going to get 17 feet. So that means our lateral area is going to be 50.24 feet times 17 feet. Can't forget to divide by 2. Gives us 427.04. That is square feet. So that is from the cone. And again, we left out the area of the base because the base is covered by the sphere. So that's not part of the surface. It's not exposed. Next, we need to do the sphere. Surface area of a sphere is 4 times pi times radius, which this radius is 8, right? Squared. Why did I just put in divided by 2? Because it's half a sphere. So if I multiply that all out there, I'm going to get 100.48 square feet. Is the area of that sphere, or half sphere. So that comes over here, 100.48 plus the 427.04 is going to give us 527.52 square feet of total surface area. What do you think? Not as bad as it could be? Oh, I screwed up. That should be 400, shouldn't it? Should be 401. Yeah, let me try that again. I forgot to multiply by the 4. Should be 401.92. Does that look better?
Yeah.
Okay. Yeah, that was kind of a big screw up. Yeah, I forgot to do the 4. I did the pi times 8 squared and divided by 2, but I forgot to multiply by 4. So 828.96 look better for my total surface area? Okay. Yeah, if you use the pi key, you get 402.12. Yeah. When I do tests and quizzes, I'll do it both ways. I'll do it with 3.14, and then I'll do it with the pi key, and I'll accept either answer.
Yeah, we've been comparing answers.
Yeah. Yep. Okay. Next, we want to talk about something called a board foot. Exactly. A board foot is 1 foot by 1 foot by 1 inch. You guys covered this in the shop yet? Okay. Yeah, 1 foot by 1 foot by 1 inch. Or, as you said, 12 inches by 12 inches by 1 inch. If I multiplied that all out, 12 inches times 12 inches times 1 inch, I get 144 cubic inches. So even though the definition is technically 1 foot by 1 foot by 1 inch, we can just use an equivalency of 144 cubic inches for board foot. And what that allows us to do is, well, all sorts of things. Let's say how many board feet we're going to put the term nominal. How many board feet nominally are in an 8-foot 2x4? Now, when I say nominally, the reason I said nominal is because a 2x4 is actually 1.5 by 3.5, right? 1.5 by 3.5 inches. But we're going to use the nominal dimension, because if you went to buy a 2x4, if they're giving you a board foot price, they're going to charge you 2 inches by 4 inches. They're going to charge you nominal dimension. So the volume of that 2x4 is the area of the base is 2x4, or 8 square inches. So what I'm doing is I'm treating the end of that board. I've got the board looks like this. I'm treating the end of the board here as the base. So it's 4 inches by 2 inches, or 2 inches by 4 inches, either way, giving me an 8 square inch base. Now the length being 8 feet is how many inches? 96. 8 times 12. So that gives us a volume of 8 inches squared, the area of the base, times that 96 inches of length, which is going to be 768, I believe, cubic inches. Yes? No, not 8 squared, just 8. It's 8 square inches, but it's not 8 square. It's just 8.
Yeah, 768.
768. So that is cubic inches. To get it into board feet, take 768 cubic inches over 1. And we're going to multiply by cubic inches on bottom, board feet on top. 1 board foot's 144. So you can see here the cubic inches cancel out. Since the 144 is on bottom, is 768 divided by 144. 5.33 or 5 1/3 board feet. You just divide by 144. Now there's a conversion that's used if you're going to do a lot of stuff. There's a thing called board feet per linear foot. And that is found by taking a board 1 foot long and finding how many board feet are in it. So for a 1x4, we are looking at 1 inch by 4 inch by 1 foot or 12 inches long. Its volume is 1x4 times 12, right? We know the 1 times 4 is the area of the base times the length of 12, which is going to give us 48 cubic inches. If I just put that over 144 right now, that's going to give me 1/3 or 0.3 board feet. So what this is saying is that a 1x4 is 1/3 board foot per linear foot. How is that helpful? Well, let's say we order 27 12-foot 1x4s. We know that 1x4 is 1/3 of a board foot per linear foot. So we're just going to find total linear feet. Which is going to be just 27 times 12. Otherwise known as 334 feet. Now that is linear feet. So we take 334 feet over 1. Now this conversion factor works a little different. Well, it doesn't really work. It's really pretty much the same. For 1x4s, it's 1/3 board foot per 1 linear foot. So the board feet cancel out. We've got 334 times 1/3, which is 111 1/3 board feet. Does that make sense? You got your what's that? Okay. Let's say we have 2x8. And we're going to order 19 16-footers. So the first thing I'm going to do is I'm going to find that board feet per linear foot. That's 2 by 8 by 12 feet, 12 inches, right? So 2 by 8 by 12 is,
12 inches.
yeah, 1 foot long. Two by 8 by 12 is 192 cubic inches, correct? Divide by 144. One and 1/3. What that is saying is there's 1 1/3 board feet per linear foot, per foot of length. So the total length here, we have 19 16-footers. It's 19 times 16, which is going to give us 304, I believe, feet. So we're taking that 304 feet, 1 1/3 board foot per linear foot. So the feet cancel out. We just got board feet. 1 1/3, that's going to give us like 405.3. 405.23 board feet. That's it. Okay. There's more to it, but we're out of time, so I'm going to give you a packet on board feet here quick.